All right, everyone. Thank you very much for joining us for the latest Uplink episode. So in today's episode, we're going to talk about our latest platform integration with Adafruit IO. My name is Del Gamel. This is my 4th year at Helium, and I'm responsible for IoT products. With me today is my coworker, Kent Williams. Kent, why don't you introduce yourself?
Yeah, hey everyone, my name is Kent Williams. I'm a software engineer at Helium, and I'm on what we call the developer engineering team. We basically help create tools and documentation to help developers on Helium in any way we can.
Great. So, next slide. So here's what we plan on covering today. I'll give a background on the Helium network, talk about things like the progress we've made, some interesting real world use cases, so companies that are using the network today. Then I'll hand it off to Kent to provide us a demo of our latest integration with Adafruit IO. So he'll do that demo. And if you have questions, which we love to hear, we are reserving time at the end to go through those. During the uplink, please feel free to add the questions in using the chat function. In addition to that, there will be a recording of the presentation. So all these uplink episodes get uploaded to our YouTube channel. So be sure to check those out if you missed any of the previous ones that we've done. With that, so quickly about Helium. So Helium was founded in 2013, and at the time, the founders saw some really interesting opportunities in the IoT space, and they discovered that it was really difficult to simply get device data to the internet. They were coming from software backgrounds. They had, worked on, created, built, and sold companies in the past, and they identified a huge opportunity. What if somebody could make it very simple, build out these wireless networks, and streamline the process of getting that sensor data from the physical world and seeing it in the digital one. So we're very privileged and fortunate to be backed by some very reputable venture capitalist firms who shared in the vision of the original founders and also feel there's a huge opportunity in this space. So folks like Coastal Ventures, Google Ventures, Mark Benioff, and then in the most recent round, Union Square Ventures and Multicoin Capital. So the founders had discovered that it was a very interesting problem about how do you create a purpose-built network for IoT devices? So there's a number of different approaches. One approach could be that you try to deploy and build a bunch of infrastructure, essentially trying to become a mini telco. The other way that you could try to do it is you buy a bunch of infrastructure, or you actually just tell users to go buy their own infrastructure and get them to try to deploy their own networks. Both methods are not very optimal. If you try to go out as a company and lay all this infrastructure out, it's going to take time and it's going to cost a lot, and the economics don't really work. And for the DIY approach, companies don't want to be in the business of network building. They want to deploy their sensors and take action on the data. So for the when Helium was approaching this problem, they thought, well, what if we kind of flip the model on its head? And instead of either Helium Inc. trying to build up this network or asking customers to do it, what if there's a way that we could incentivize anyone to participate and create this wireless coverage. And so that's what we did. Quickly, hosts for providing coverage and allowing devices to send data to the internet. Hosts will earn a cryptocurrency, HNT, and through that process, back then, and what we've seen is you can build a wireless network much quicker than any other way. So in the early days, when we were initially building the network, we actually built our own hardware. And if you see that one hotspot with the white and the black dot, that's the original Helium hotspot. But we knew that if we really wanted this network to grow and we wanted to make it decentralized, we couldn't be the only ones building the hardware and shipping it. So to remove ourselves from becoming this bottleneck and to make the network really decentralized, we've worked with a number of hardware partners. So we had a recent announcement about it, but folks like Nebra, BRAC, and others are already producing compatible gateways that users can plug in, start providing coverage, and start earning that new cryptocurrency, HNT. So that's on the hardware side. On the network architecture, we're doing something interesting. We are combining the LoRaWAN wireless protocol with our Helium blockchain. So what this means is that we are absolutely compatible with any off-the-shelf LoRaWAN device out there. So there's no updates needed to firmware. If it's running on LoRaWAN, then you can start using the device on the network. With blockchain and the routing tables that we're using, you get this real device roaming. So a device is onboarded and connects in Alaska, somehow finds its way down in Miami, it's fine. It can, as long as there's coverage available, then it will be able to pick up those signals and send the data. Micro-payment transactions, something that's unique about the network is that with the model that we have, there is no cost to use the network other than something called data credits. And with the use of data credits, connectivity costs are kept very, very low. So as an example, if you had a device that was sending data every 5 minutes, after a year, it would only cost a little over $1. And then finally, something that we get with blockchain, I mean, blockchain is critical to create this decentralized network, to be able to reward hotspot hosts for providing coverage. We also get this cryptographic proof of time and location for connection events. So when a device connects, the time that it connected and the location of the hotspot that sent the data is recorded on the blockchain. And so you can think of that as like a digital ledger for those connection events. So you see that really interesting or nice globe image. We have, I think last I checked, there's over 17,000 hotspots that have been deployed. So it took, I think, around a week to go from 16,000 to 17,000. We anticipate that it's going to grow much faster once all these new hardware partners are on board. So this network is accelerating at an unprecedented rate. We're already the largest public IoT network in the US, and that's going to continue to grow. We mentioned the low cost of what that connectivity actually works out to, and compatibility. So use any of these LoRaWAN sensors and get that that blockchain proof of time and location for sensor data. So just quickly, there's a number of companies that are using Helium. If you go to helium.com and go to the use section, there's like an updated list that continues to grow, and we need to probably do a better job of presenting those companies. But just as an example, Conserve, they do some interesting work with museums and art galleries to protect artifacts by monitoring temperature and humidity. Naui is working with commercial real estate owners and monitoring and detecting leaks, so kind of smart water applications. Caraband is has wearables and doing interesting stuff for not just older people with dementia and tracking them, but also looking at applications for COVID-19 and social distancing and contact tracing, which is similar also to what SmartMavic is doing as well. So if you want to get started and participate, if you haven't already, so on the coverage side, go visit helium.com store, and we have links to the different hardware vendors that are providing gateways. Now there's both indoor and outdoor varieties. And in terms of coverage, go to console.helium.com. You can sign up, you can get a free account, and then everyone who signs up, we give them 10,000 data credits for them to start experimenting and playing with it. So with Console, we have, from a strategic perspective, we are looking at how do we get more communities exposure to Console, because we feel that once they experience Console and they pair that with the amount of coverage that continues to grow, we feel that they will be hooked and they will start using Console and standardize on it. Now, part of our strategy is to integrate with other popular, well-known IoT platforms, and Adafruit IO is the latest. So what we've done is we've created a pre-built integration to really streamline the process of getting data from your device through Console in the network to the Adafruit IO platform. So this is, we are looking at common or popular platforms to partner with. There's no preference. We just, based on demand, we get users asking us for, platforms, and we do an assessment, and then we make a decision. So with that, I'm going to hand it off to Kent, who will take us through that process.
All right, thanks, Al. So we'll go to the next slide there. Oh,
sure. There. Oops. Sorry. Can you still see my screen? Hello?
Not yet.
Okay. There we go.
All right, great. Thank you. So I'm going to do a little demo here just to go over the hardware I have sitting in front of me. I'm using the Adafruit Feather M0, probably Adafruit's most popular LoRaWAN board. It's got the RFM95 LoRa module on it, and that has the Semtech SX1276 radio in it. And then just as a popular fun sensor, we got the DHT22, which gives us temperature and humidity. And Dol, do you mind going to the next slide? Okay, so before I start sharing my screen to start configuring things, I just wanted to point out that we do have a guide that goes step by step through the whole entire thing. So setting up the hardware, programming the firmware, and configuring Console. So if you want to follow along or do this afterwards, please visit that link. I'm sure we'll have it in the description of the video later on. So let's go to my screen. All right, so hopefully everyone can see that now.
We can.
All right, so yeah, we're going to start just from the home page here. So I already have this device streaming data, so we're going to go ahead and look at that just to confirm before we start setting up the integration. So yeah, you can see this is my Feather device. I've got data streaming here roughly every 5 seconds or so. And we got uplinks coming, and you can see that I don't have any integration currently configured, but we're going to do that right now. So let's go ahead and set up the integration. We're going to go to the integrations tab. And before I jump into the Adafruit IO one, I just wanted to go over real quickly. Our core building blocks of integrations are really HTTP, MQTT, and AWS IoT Core. These pre-built integrations are really building on top of these core ones. We just do some things in the background to either automate the creation of things or just streamline the process so that people can get data to the service they want a little quicker. So that's what we've done with the Adafruit IO one. As you can see, it's actually using MQTT. So yeah, let's go ahead and jump in. So the first two things you'll need, the only two things from Adafruit, is a username and a key. So we'll go ahead and go to the Adafruit IO dashboard. So yeah, if you can register for free, it's just io.adafruit.com. When you log in, you'll be presented with your dashboards page. We don't have any right now, so I won't see anything, but what we need is the key. So they have this handy button right here. You just click this, up comes this pop-up, and we are presented with our username and key. So let's go ahead and just copy and paste that. All right, and the third thing we need to enter here is what's called the group name. So the group name is basically how the data is going to be grouped together on Adafruit IO. So because you can add this integration to hundreds of devices, we want to be able to distinguish what device the data is coming from. So what we've done here is we're using what's called templating tags. And what this does is you can use these specific tags. There's a couple others. You can use the device name. But what it does is when the packet is actually received, we'll replace the ID of that device at that time and before it's sent to Adafruit IO. So it's just a handy way of doing it basically at runtime so we can organize that properly on Adafruit IO. You could wipe this away and just name it whatever you'd like. The problem is that it's just going to bucket all the data streams into one group, and it might be hard to distinguish which device it's coming from. All right, so third step, name your integration, simple. I'm just going to name this Adafruit IO. And then, so what this is doing in the background is it's going to create what's called a label. Labels are basically how you interconnect everything on console. So you connect functions and integrations to devices. And you'll see how that's used in just a little bit, but just know that's what this is basically doing. And then the fourth and last step, and probably what's the most complex in the background, is choosing your decoder. So the reason this is important is when our device sends data and it's received by console, we have to know how that data is organized. And so you have to basically encode the data with some system ahead of time so that the device can encode it and console can decode it. And so you can use any encoding scheme you like by just going to custom. You would go to functions, you would create a function decoder, which is basically a small JavaScript function that would extract the data from your payload, and you would just be able to select that right here. What we've done though is we've offered the ability to pick Cayenne LPP, and this is probably the most popular LoRaWAN development encoding scheme out there. And so we figured this is going to meet the most amount of use cases. And what we do is by choosing this in the background, we're automatically creating a decoder that's going to decode Cayenne LPP encoded data. And then we also create what's called a template, which is going to extract those values from the decoder and format it in the specific way that Adafruit IO is expecting. And I'll show you what those look like just after we create it here. So let's go ahead and create. Okay, great. So you can see that this is just an MQTT integration. We've just, we've done the composition of the endpoint and the topic. Down here, you can see that the label was created and attached to this integration. And then down here is the templating that I mentioned. So this little widget basically allows you to construct templates when you're trying to figure out how to get the values out of your payload and off to wherever they need to go. So right here is an example of a Cayenne LPP decoded output. So you can see like GPS type, a temperature type right here, and then the value listed here. And so what this templating language allows us to do is extract those values out and format it in the specific way that Adafruit IO expects. And so we can actually just run this through, and this is what it would look like before it was sent to Adafruit IO. So that's already created in the background. We don't have to touch that if you're using Cayenne LPP. And then I can show you the function that was created. So yeah, here's a decoder function for Cayenne LPP. It had the Adafruit IO label attached to it. And so now we're basically ready to do the final step, which is what we call attaching the label. So this will basically attach the functionality of the Adafruit IO integration to this device. And so you can do this to one device on the device page like this, or you can go and add it to hundreds of devices on the devices page. We're just going to add it to this one for now. All right. And then you can see also right here, it shows which integration is associated with this label. And so we should see in our data graph here that the dots turn blue now, and this indicates that there's an integration and that it's now being sent, and we get a successful receipt from the service. So it's being sent to Adafruit IO successfully now. So from here, we're pretty much done with the configuration on console side of things. We're going to jump over to Adafruit IO. We're going to go to our feeds, which is basically the streams of data that's coming in. And so here you'll see this box outlines the group of data from this device. And this is the group name, which is a long UID, but always unique, which is handy. If we go back to console, we can see this is the same ID that was used when that was sent. And so we can look in here. Here's the humidity data, some historical values, temperature as well. Everything's looking good. Okay, so at this point, let's go ahead and create a dashboard, which is probably most common use case on Adafruit IO. I'm just going to create a simple one here called demo. So you start with a blank slate. You just go to this wheel up here. We're going to create a new block. I like these gauges for temperature. So right here, this is your feeds. Every time you go to create a block, you'll be presented with your data feeds to select from. So let's go ahead and select the temperature one. Call this temperature. The default settings work pretty well for this, so we'll just leave those. And then humidity. Let's go ahead and create that. All right, and then data stream. I really like this one because even if the values are the same, you can see the timestamp stream of them coming in, which is pretty handy. So you know that things are still working. I'm going to go ahead and edit this layout because I'm going to bring a chart in here below this. Okay, let's do a line chart with both temperature and humidity this time. I'm going to make it 1 hour so that we can see the data more precisely. And these defaults usually work pretty well. Pull this out. All right, and the graph, the data points usually take a little time to populate. Let's see here. Just make sure we got the right settings here. Yep, 1 hour. Okay, cool. There it is. So yeah, this is just a really simple, quick dashboard you can get up and running in a couple of minutes. You can share this dashboard publicly by just flipping this toggle right here and sharing the URL. So it's nice and handy. Let's go look at some other services that you can do within Adafruit IO. So The next thing is triggers. This is pretty handy. So say you want to do something if, say, the temperature value is greater than some specific value you're setting. So let's say 40, then you can either, if you have the plus version, you can do emails. Otherwise, you can publish to other feeds within Adafruit IO, or you can send a webhook to maybe a server that you run or some other service that you want to activate at that time. There's also scheduled triggers. What this basically allows you to do is publish your data within Adafruit IO out to some other service, like altogether. So every 30 minutes or so, you could just group it all together. And here they have some templates here, just like we were using on console, to fill in those values and push them off to another service, which is really cool because a lot of services don't allow you to do that really easily. All right, and the last thing is what they call services. I think this is really awesome. So you've done all the work to get your data into Adafruit IO nicely. And what they're doing here is basically allowing you to forward it to other services really easily. So IFTTT or Zapier, you can make unlimited amount of automated things with those two. And then these are actually for going the opposite direction. So bringing some time data down to your device, or say you need a random number for some functionality on your device, you can pipe that actually down to the device. And yeah, that pretty much completes a quick run through of what you can do on Adafruit IO. So I think we'll transition to questions now.
Thanks, Kent. Let me, just in case people weren't aware, I will pull up the QA slide. Actually, this is gonna. All right. So feel free to add questions in the chat. But there's, Ken, there was one, somebody was asking about the firmware that you use for the for your device.
Right. So yeah, you can find that on the guide for that link that we provided. It's right there. It's in a GitHub repo called LongFi Arduino that's part of the Helium organization. So yeah, you can find that example through there. I'll link it in the chat as well.
Okay, thank you. Somebody asked you devices, do you need the devices certified by Helium to work on the network? Nope. As we mentioned, as long as they are compatible with LoRaWAN, it'll just work. Somebody asked, I think, a question related to duty cycle in terms of the 1% rule. Doesn't that affect our data rates? So yes, you still need to respect duty cycle if you are in EMEA, if you're in Europe. In terms of data rates, it all, so I think it means you're asking about data, cost of data, and it's all based on demand. So you only pay for the packets that are sent from your device. Somebody's asking about the Bobcat console for pre-sale. Not sure. I would recommend going to our Discord channel, our Discord, and going to there. We do have a Bobcat channel, so any information about Bobcat is probably best to be answered there. So Ken, I think this one is for you. The person asked, as far as I know, there's really not much LoRaWAN stack support for SAMD21 plus SX1276. What kind of software library is used here? I assume go to the documentation and that'll have all the details about what we're using.
Yes. Yeah, we're using the LMIC LoRaWAN library for this particular example, which does work just fine with the SAMDs.
Okay. Oh, so Marcus asked, is your sensor in the house or outside for the demo? Did you have it Or where was your sensor that you were collecting the temperature and humidity?
Yeah, it happens to be inside, but it could have just as easily been outside. Sure. I can get hundreds, long ways away.
Yeah. Somebody asked, can you discuss how to debug? That's a really big topic. We do have a debug feature in console. So if you go to console, go to device, the specific device that you want to start debugging, you would click on what looks to be, well, a bug, and that will open a pane, and that will give you a lot more information that you can get from the event log. And can downlinks be sent from Helium console and or Adafruit IO? So yes, downlinks can be sent from Helium console. Not sure for Adafruit IO. Are downlinks supported in Adafruit?
That's not something we have attempted yet, but it's not necessarily not possible.
Okay, great.
Yeah, so we can reach out on Discord and we can answer that more completely.
Cool. Does it matter how close sensors are to Helium hotspots? So very similar to just like other LoRaWAN networks and gateways, same rules apply in terms of radio signals and frequencies and SNR. Is it possible to get a recording of this? Yes, as I mentioned, all of these are recorded, uploaded to our YouTube channel. How many devices can a hotspot access point support? So the devices have a minimum of 8 channels. And so it really depends on how often those devices are transferring data. So it's a really difficult question to answer because there's just a number of variables involved. I don't know, Kent, if you have any more.
Yeah, I would say it's highly variable. Depends what the devices are doing, how many you have, how fast they're sending.
Right.
There's several different things. So it's not something we can really just throw out a number for without some more details.
Right. Other than the RFM95, what other hardware is needed just to get started? I don't know much about the hardware needed. So when you say started, I don't know if you mean started using the network or starting using the Adafruit IO integration, but actually the answer is pretty much the same. You just need to make sure that the hardware is LoRaWAN compatible. And there are hundreds and hundreds of devices that are available out there that you can just pull off the shelf and start using. And for so that's available. We also, there's a channel in Discord of sensor device or something. I'm blanking on the name, but that channel is sensor dev, right? And so that channel is specifically devoted to folks sharing their experience using other devices. I have a Feather M0 RFM95. I'm not getting anything on my console. Trying to debug this. If you're having an issue, then please, probably the quickest way is to go to Discord and post it in the Helium console channel. Any plan for ABP support? We'd like to hear your use case for it. That's not something that we're specifically looking at right now, but I'd love to hear why you would need ABP. The issue that we understand with ABP is it's less secure than OTAA, and we don't really get a lot of requests for it. So I'd love to hear why you need it, what your use case is. For Helium hotspot, do you need it to be connected to the internet? Yes. So that's a new one. No relaying feature for LoRaWAN. Please post the Adafruit documentation link here. Okay, if you saw that question. I think
Which one
in
again?
the chat, the Adafruit documentation link. Oh, somebody already did it.
Yeah, it looks like Joey just linked it.
Yeah.
Thanks, Joey.
Thanks, Joey. Is the ability to mine AT&T with a third-party gateway supported yet? Yes, thank you. And I did not set John up to ask that question, but thank you, John, for asking. So as we mentioned in the presentation, we are onboarding a number of hardware manufacturers. So Nebra, Frac Wireless, and a couple others. That if you go to helium.com/mine, you will be able to see which devices, which gateways. Do you have a link to the Adafruit.ino for the RFM95 Feather? So I think that's the document that Kent included.
Yeah, it's referenced in that guide that we just posted there.
Yep. And yeah, you're welcome, Daniel. Any other questions? So John asked, so Adafruit is for creating devices and monitoring them. Adafruit is, John, is a platform that you're sending data from the devices to. I know it's kind of somewhat confusing because so you've got Adafruit IO, which is a platform that we had discussed. You know, what this integration is all about. But Adafruit itself also creates devices or manufactures devices. But this is specifically for Adafruit IO, the platform, and it doesn't matter what device you use. Like you can use whatever LoRaWAN device to onboard and send that data to their platform. So hopefully that's clear. All right. Well, I'd just like to say on behalf of the team at Helium, thank you very much for joining and engaging with your questions. We really appreciate it. We, as I mentioned before, you know, we want to attract as many IoT communities to the network and to console, and so you are going to see more of these integrations as we continue. And if there's some that you are using or you think are very popular, feel free to share them in the Discord channel, specifically the console one. And with that, enjoy the rest of the day. And thank you very much. Kent, I don't know if there's anything you want to.
Nope, all good. Thank you, everyone.
All right. Thank you. Have a great day.